Hello everyone, we're doing worksheet on upper and lower bound. This worksheet contains almost all questions from IGCSE papers related to this topic from 2019 backwards till I guess 2010. Alright, before we start the past paper questions, let's quickly discuss what's upper bound and lower bound. So if we look at the first picture that I've attached right here, if we need to find the largest value, just a second please. Alright, excuse me for that. Okay, so 32, we have a number 32 and we need to look for a largest value that will round off to 32. So that will be 32.5. Anything bigger than 32.5 will get rounded off to 33, and similarly anything bigger than 31.5 will be rounded off to 32, and anything less than 31.5 will be rounded off to 31. So this is how you find the upper bound and lower bound. We have to write 32 centimeter correct to the nearest centimeter. So to find the upper bound, what the method is that correct to the nearest centimeter means 1 centimeter, you divide it with 2, you get 0.5. When you add 0.5 to 32, you'll get upper bound, and when you subtract 0.5 from 32, you'll get the lower bound. So this is the procedure of finding the upper bound and the lower bound. So let's try. Okay, starting with these example questions, we have to 32 centimeter correct to the nearest centimeter, find the upper bound and the lower bound. So same method we just did. 1 divided by 2 is 0.5. When we'll add this to 0.5, we'll get the upper bound 32.5. And when we'll subtract this to 32, we'll get the lower bound 31.5. Okay. Next up is 42.3 correct to the nearest 1 decimal place. So 1 decimal place means 0.1. Divided with 2, we get 0.05. Now in 24.3, add 0.05. Add 0.05, we get 24.35, and then when you subtract 0.05, we get 24.25. So the upper bound is 24.35 and the lower bound is 24.25. Question 3. 50 degrees correct to the nearest degree. So correct to the nearest 10 degrees. So divide 10 with 2, we get 5. Add 5 to 50, we get 55. So 55 is the upper bound, and subtract 5 from 50, we get 45, which is the lower bound. Then we have 4.2 meters correct to the nearest 0.1 meter. So again divide 0.1 with 2, we get 0.05. So add this to 4.2, we get 4.25 to get the upper bound 4.25, and then subtract from 4.2 to get the lower bound, which is 4.15. Okay. Next is 958 units correct to the nearest 100 units. So 100 divided by 2 is 50. Add this to the value, we get 1008. So that is the upper bound 1008, and when you subtract 50 from 958, we get 908, and that is the lower bound. Okay. Next up is 200 centimeter correct to the nearest 100 millimeter. So now there is a conflict in the unit. This is in centimeters and this one is in millimeters. So first we'll make the units same. So let's change 100 millimeters to centimeters first. To change millimeters to centimeters, we divide with 10. So we get 10 centimeters. This will become 10 centimeter. Now divide this with 2 and we get 5. Add 5 to 200. We get the upper bound, which is 205, and subtract from 200. We get the lower bound, which is 195. Okay. 8 kg correct to the nearest integer. So integer means 1, and then 1 divided by 2 is 0.5. So add this to 8. 8.5 is the upper bound. Subtract it from 8 and that's the lower bound. So 8.5 and 7.5. Yeah. 5140. Correct to nearest 3 significant figures. Now this is relatively trickier. Okay, so let me write the number 5140 correct to 3 significant figures. So this is the first significant figure, this is the second, this is the third. So which place is this? This is the 10th place, right? So third significant figure is on the 10th place. You write that down, 10 on the 10th place, and then you divide 10 with 2, we get 5. You add 5 to 5140, we get the upper bound 5145, and you subtract it from 5140, we get the lower bound, which is 5135. Next up is 74 correct to 2 significant figures. Now let's determine the position of the second significant figure. We have 74. Okay, so we were on question 9. 74 correct to the nearest 2 significant figure. So the second significant figure is on the units place, 74. So this is the second significant figure on the units place. So we write 1 divided by 2, which is 0.5. So the upper bound will be 74 plus 0.5, which will be 74.5, and the lower bound will be 73.5. Question part 10, which is 7.6 kilometers correct to the nearest 2 significant figures. Now again the second significant figure is 0.6, which is on the 10th position. So 0.1 unit place, 10th unit place, which is also 0.1 in decimals. So this divided by 2 becomes 0.05. So add this to 7.6 and we get 7.65, and subtract it from 7.6 and we get 7.55. These answers here are wrong. I probably made some typing mistake here, so fix this at 7.65 and 7.55, and in the end we have 0.23 correct to 2 significant figures. Now this 0.01 position is in the the second significant figure is 3, which is at the 100th place, which is 0.01. Divided with 2, we get 0.05. Add this to 0.23, so we get 0.235, and subtract it from 0.23, we get 0.225. So this is how we find upper bound and lower bound of numbers correct to the nearest whatever. So now let's jump to the past paper questions. Okay, so question number 1. The length of a car is 4.2 meters, correct to the nearest 1 decimal place. So 1 decimal place is 0.1. So for question 1, 0.1 divided with 2, we get 0.05. So write down the upper bound and the lower bound for the length of the car. So we add 0.05 to the original value, and we subtract 0.05 from the original value. So we get 4.25 and 4.15 as the answers. Question 2. An equilateral triangle has side of length 12 centimeters, correct to the nearest centimeter. Now nearest centimeters means nearest 1 centimeter, divided with 2, we get 0.05. Now find the lower bound and the upper bound for the perimeter of the triangle. So the perimeter upper bound for the perimeter will be 12 plus 0.05, which is 12.05 into 3 will give the upper bound, and 12 minus 0.05, wait, this is not 0.05, this should be 0.5, so just 0.5, yes. So and then subtract 0.5 from 12, we get 11.5. So find these values. 3 times 12.5, which is 37.5, and then 3 times 11.5 is 34.5. Question 3, which is an equilateral triangle has length 61.1, correct to the nearest millimeter. So 16.1, correct to the nearest millimeter. So 1 millimeter, and the length was in 16.6 centimeters. So we have a unit conflict in the question. So first we need to ensure that the units are the same. So let's change 16.1 centimeters to millimeters. So this becomes 161 millimeters. Now divide 1 with 2, we get 0.5. So we need in the end we need upper and lower bound both. So we write 3 times 161.0.5 and plus 161.5, because we're adding 0.5, and the other one will be 160.5 when we'll subtract 0.5 to it. So we get answers in millimeters. 3 times 161.5, which gives 484.5, which is in millimeters. And then I get 3 times 160.5, which is 481.5 millimeters, but the actual value should be in centimeters. And even in the answer space, the answer would be written dash centimeters and dash centimeters. So we get 48.45 centimeters and 48.15 centimeters. Alright, question number 4. The sides of a triangle are 5.2, 6.3 and 9.4, correct to the nearest millimeter. Calculate the lower bound for the perimeter. So first, again there's a unit conflict. Let's change all the lengths into millimeters. 42 millimeters, 63 millimeters and 94 millimeters, and correct to the nearest 1 millimeter. Divide 1 with 2, we get 0.5. So the lower bounds of these would be 41.5, 62.5 and 93.5. We have to find the perimeter, so add all 3 of these lower bound lengths and we should get the answer. So 51.5, and then we'll change the value back to centimeters. 51.5 plus 62.5 plus 93.5, this gives 207.5 millimeters. Divide it with 10 and we get 20.75 centimeters. Answer for question 4. Question 5 is the length of a rectangle is 9.3, correct to one decimal place. So the width of the rectangle is 7.7, correct to nearest one decimal place. Write down the lower bound and upper bound for the area of the rectangle. Alright, so we have length 1 centimeter, correct to nearest to one decimal place, which makes 0.1, divided by 2 we get 0.05. So add this to 9.3, we get 9.35. Subtract this from 9.3, we get 9.25. And then to 7.7 we add 0.0, yes, 7.7, correct to the nearest one decimal place as well. So this becomes 7.75 and 7.65, lower and upper bound. So write down the lower bound and upper bound for the area of the rectangle. So to find the bigger area, upper area, multiply the bigger values. Length times width. Okay. So for upper bound area, we'll simply multiply the upper values, and for the lower bound area we'll simply multiply the lower values of the length and the width. So let's see what we get. 9.35 times 7.75, which is 72.46. This is 72.4625. The answers for upper bound and lower bound are not rounded off to three significant figures, because if you do that you'll end up getting different answers. This becomes 70.7625. Question 6. The circle has radius 8.5 centimeters, correct to the nearest 0.1 centimeter. The lower bound for the area of the circle is p pi, the upper bound for the area of the circle is q pi. Find the value of p and q. So let's find the area upper bound. So for upper bound area, I'll need upper bound for the radius as well. So again I'll divide 0.1 with 2, I'll get 0.05. So the upper bound area will be pi times 8.55 square. I'll add 0.05 to 8.5. So that becomes, and this should be equals to q pi. Yes, q pi equals upper bound area 8.55 square. So q is simply equals to 8.55 square. $73.1025. Yes, this is the answer for Q. 73.1025. Okay. Next we have to find the value of P. So P pi equals to the lower bound area. So the lower bound for the radius will be 8.5 minus 0.05, which will be let's just do it to be sure. Yes, 8.45. So P is simply 8.45 square. So 8.45 square is 71.4025. So this is the answer for P. Okay, question number 7. The sides of a square are 8 centimeter. Correct to the nearest centimeter. Calculate the upper bound for the area of the square. So simply it's correct to the nearest 1 centimeter. 1 divided by 2 is 0.5. So 8 plus 0.5 is 8.5. This is the upper bound for the length. So to find the upper area, we'll simply multiply 8.5 with 8.5 or find 8.5 square. This should hopefully give this value. So next up is part 8. The sides of a square are 15.1. Correct to the nearest 1 decimal place. So again 1 decimal place means 0.1. Divided with 2 we get 0.05. In the end we need upper bound area for the square. So we need the upper values of the length. So that would be 15.15 and then take its whole square. Let me see what we get. 15.15 square. This gives 229.5225. So 229.5225. Remember, we're not supposed to round off answers for upper bound and lower bound. Okay. Question 9. The length of sides of a square is 12 centimeter. Correct to the nearest centimeter. Calculate the upper bound for the perimeter. So all we need to do is find the upper bound length, which will be 12.5, and then find the perimeter. 4 times 12.5. 4 times 12.5 is 50. This is 9 part A. 9 part B. Joe measures the length of the rope and records her measurement correct to the nearest 10 centimeters. Upper bound for her measurement is 12.35 meters. Write down the measurements she recorded. Okay, so the first thing problematic about this question is there's a unit conflict. This is in meters and then correct to the nearest 10 centimeters. So let's first fix this conflict. Let's change 12.35 meters to centimeters just for now. So this becomes 1235 centimeters. Now to find its upper bound, we don't have to find the upper bound. This is the upper bound for a particular value. So there's a value whose upper bound is this. And how do we find the upper bound? It's correct to the nearest 10 centimeters. So 10 divided by 2 is 5. So there's some value. When we add 5 to it, we get 1235. So that value will be 1230. And this is in centimeters, but our answer should be in meters. So divide it with 100 and we get 12.3. Question 10. Which is the side of a square is 6.3 centimeter. Correct to the nearest millimeter. Lower bound of the perimeter of the square is u centimeters and upper bound for the perimeter is v. Calculate u, v minus u. Okay, so the side of a square is 6.3 centimeters. Correct to the nearest millimeter. So we need to find the lower bound perimeters. So 6.3 centimeters correct to the nearest 1 millimeter. So to fix the unit conflict for now, we'll change this into millimeters. So this becomes 63 millimeters. Now upper bound for 63 millimeters will be 63.5 millimeters because we'll divide this with 2. And the lower bound will be 62.5 millimeters. Alright. So calculate the value of u. U was the lower bound perimeter. To find lower bound perimeter of the square, we'll multiply the smaller value with 4. So 4 times 64, 62.4, 62.5, we get 250. So 250 is in millimeters. We need the answer in centimeter. Divided with 10, we get 25. Similarly, calculate the value, what was v, and the lower bound of the perimeter of the square is u and the upper bound for the perimeter is v. So how do we find v? V is the upper bound perimeter. So that would mean 4 times the upper value. So 4 times 63.5 is 254 in millimeters. Change this into centimeters, so 25.4. So this is V now, 25.4. Next, what do we have to do? We have to calculate the value of V minus U. So we have to find V minus U. V was 25.4 and U is 25. So the answer is 0.4. Question 11. The area of a square is 42.5 centimeters square. Correct to the nearest 0.5 centimeters square. Calculate the lower bound of the length of the side of the square. The area of the square is 42.5 centimeters square. Correct to the nearest 0.5. Calculate the lower bound for the length of the square. Okay. So the length formula is area divided by width. No, in fact, length for is simply under root of area in terms of a square. Yes. So we need to find the lower bound of this length, which means we need the lower bound area. So lower bound area will be 42.5 plus 0.5 over 2 is 0.25. So this becomes 42.75. So lower bound area is under root 42.75, and this gives us 6.538. Oh, the question said the lower bound length, not the upper bound. Sorry, the lower bound, yes, lower bound length. So this would be minus, and this would be 42.5 minus 0.25, 42.25. So this becomes 42.25, under root of which becomes 6.5. Okay. Question 12. Joe measures the side of a square correct to nearest 1 decimal place. He calculates the upper bound for the area of the square as 37.8225. Work out Joe's measurement of the side of the square. Okay, so 1 dp means 1 over 2 equals 0.5, and then he calculates the upper bound for the area equals 37.8225 equals up. This is the upper bound area, so this is the square of upper bound length. So what will be the upper bound length? Whatever is the value of the original length plus 0.5. Okay, now we need to find the value x. So we take under root of 37.8225 and then subtract 0.5 from it. So we first take under root of 37.8225, and then to make x the subject, take 0.5 to the other side. 5.65 is the answer. Oh, there's a mistake in this question again. This was 1 decimal place. So 1 decimal place is 0.1. So 0.1 over 2 is 0.05. So this is 0.05. This is also 0.05. Then we'll subtract 0.05 from under root of that value. So under root 37.8225 minus 0.05, which is 6.1. Yes, this is the answer for part 12. 6.1. Question 13. The base of a rectangle is 9 centimeter, correct to the nearest centimeter. So the upper bound will be 9.5 or 8.5. The area of the triangle is 40 centimeter square, correct to the nearest 5 centimeter square. So the upper bound will be 42.5 or 37.5. Calculate the upper bound for the perpendicular height. So the formula for area is equals to half into base into height. Make height the subject, so we have to do 2a over b to find height. Now we need the upper bound for the perpendicular height. So to find the upper bound of the height, we should have the upper bound of the numerator and lower bound for the denominator, so that we get the biggest value from these possible 4 combinations. Alright, so I'll repeat again. To find upper bound of the height, we have to find upper bound of the area and lower bound of the base. So height upper bound will be, area is 42.5 over base is 8.5. The answer is, so there's also a 2 being multiplied with it, so the answer is 10. Okay, question 14. The rice is sold in 5 grams and 120 grams packs. The mass of both packs are given correct to the nearest gram. So 75, upper bound is 75.5, and then 74.5, and then 120 grams, upper bound is 120.5 and 119.5. Calculate the lower bound for the difference in mass between the two packs. So we need the lower bound for the difference, so we'll be finding the difference between these two, and we will be choosing one value from 120 minus one values from 75 range. Okay, now we're finding difference between two numbers and we need the upper bound answer. No, calculate the lower bound for the difference. So we need the lower answer. Say we need the lower answer. So whenever we need the lower answer and two numbers are being subtracted, take lower of this one and upper of this one. So keeping this in mind, I'll take lower for the bigger value, which is 119.5, minus upper for the other value, which is 75.5. So 119.5 minus 75.5, which is 44. So let me revise. If we're subtracting two numbers, let's say C equals A minus B, and we need the upper answer, then the first number should be upper, the other should be lower. And if we need the lower answer, then the first number should be lower and the second should be upper. Similarly, if we're multiplying two values, then if this is upper, then this needs to be upper and this needs to be lower. And if this is lower, then this needs to be lower and this needs to be upper, and so on. Okay. Similarly, if two values are being added and the answer should be upper, take upper for both values. If the answer should be lower, take lower for both the values. Same goes for multiplication. If the answer is upper, take upper for both values. If the answer is lower, take lower for both the values. Question number 15. Okay. One year ago, Ahmed's height was 114 centimeter. Today his height is 120 centimeter. Both measures are correct to the nearest centimeters. So 120 correct to the nearest 1 centimeter means upper bound will be 120.5, lower bound will be 119.5. Similarly, 114 will be 114.5 because we add 0.5 to it, or we subtract 0.5 to it to get the lower bound. Alright. Work out the upper bound for the increase in Ahmed's height. So in normal case, if this is not an upper bound and lower bound question, we will simply be subtracting these two right? Now since this is an upper and lower bound question, and the question says work out the upper bound for the increase in Ahmed's height, so I need the increase in upper bound. For that I'll use upper value of this and lower value of this so that I get a bigger answer. So 120.5 minus 113.5, this gives us 7. So 7 is the answer for question 15. Question 16 is, in 2016 a company sold 2600 cars, correct to the nearest 100. So write down the lower bound for the number of cars sold. So correct to the nearest 100 means divide it with 250. So subtract 50 from 9600 and we get 9550. Answer for 16.1. 16.2. The average profit on each car sold was 2430, correct to the nearest 10. Calculate the lower bound for the total profit, write down the exact answer. Alright, so we need the lower bound for the profit, and the average profit was 2430, correct to the nearest 10 means add 5 or subtract 5. So 2435 is its upper bound and 2425 is its lower bound. Okay, calculate the lower bound for the total profit. Now total profit will be, okay, if this were a regular question, then the total profit would be number of pieces sold 9600 times cost of each piece 2430. So now, but we need the lower bound for the total profit, so we need the lower answer, and which means we need lower answers for both of these so that we get a lower answer, lower overall value. So 9550, yes, the lower bound is 9550 that we've calculated in part 1 times lower for dollars is 2425. So 9550 times 2425, which is 23158,750. Yes, we're getting this answer. So this is the answer for this part. Okay, question 17. On one day, the number of members using the exercise machine was 40, correct to the nearest 10. Each member used a machine for 30 minutes, correct to the nearest 5 minutes. So 40 correct to the nearest 10 means either 45 is the upper bound and the lower bound is 35. And 30 minutes correct to the nearest 5 minutes mean add 2.5 to it or subtract 2.5 from it. Okay. Calculate the lower bound for the number of minutes the exercise machine were used on this day. So again, if this was a regular question and we were supposed to find the number of minutes the exercise machine was used, we would have multiplied 40 with 30. One day the number of members using the exercise, 40 members use it and each member use it for 30 minutes. But now we need the lower bound answer. So to get a smaller value, we'll choose the lower value of both of these. So 35 times 27.5. So the answer is 962.5. This is the answer for this part. Question number 18. The number of spectators at 2010 World Cup match between Argentina and Mexico was 82,000, correct to the nearest 1,000. If each spectator paid 2,600 R to attend the game, what is the lowest bound for the total amount paid? Write your answer in standard form. Alright, so we need the lowest amount paid and we will be multiplying the two numbers, right? So we have 2,800 spectators and each pay 2,600 Rand, but we need the answer in lower bound of the answer, which means we need lower bound for this and lower bound for this. Now let's first calculate the lower bound for 8200, 82,000. It was correct to the nearest 1000. So 1000 divided by 2 is 500 minus 500. So this gives 81500 times lower bound for the amount of money is if each spectator paid 2600 to attend the game, what is the lower bound for the total bid? Oh, alright, and 2600 remains the same. So multiply these two values, 81500 times 2600. So it is 211. It's 2119 and then 5 zeros, and we're asked to give the answer in standard form. So the zeros here at the moment 1 2 3 4 5 6 7 8. We're moving it 8 units to the left, so when we move left the power gets added, so plus 8. Okay, question 19. Is Safia has a barrel containing 6000 ml of oil, correct to the nearest 100 ml. So 6000 correct to the nearest 100 ml will mean add 50, we get the upper bound, subtract 50, we get the lower bound. Alright, and then she uses the oil to fill bottles, each hold exactly 50 ml. Calculate the upper bound for the number of bottles she can fill. So if this were a regular question, we would have done 6000 ml divided by 50 ml. But they're asking for the upper bound of the final answer. So we'll take upper bound of this. And we can't take upper or lower bound of 50 because they haven't told us that 50 correct to the nearest 5 or 4 or whatever. So 50 will not be changed into upper or lower bound. 50 will remain the same. So next we solve it and we get 6000 divided by 50 is 120. No, but we're first supposed to write the upper bound of 600, so that is 6050 divided by 50. So 6050 divided by 50 is to 121. Answer for question 19. Question 20. Okay. A large water bottle holds 25 liters of water, correct to the nearest liter. So 25 liters correct to the nearest 1 liter. Upper bound will be 25.5, lower bound will be 24.5. Okay, because we're adding correct to the nearest liter is 1 liter divided with 2, we get 0.5, added to 25 to get the upper bound, subtracted to 25 to get the lower bound. Okay, a drinking glass holds 0.3 liters, correct to the nearest 0.1 liters. So 0.1 divided by 2 is 0.05. Add it here and we get 0.35, and subtracted from here we get 0.25. Calculate the lower bound for the number of glass of water which can be filled from the bottle. So if again this were a regular question, we would have divided 25 and 0.3. Now we need the lower bound answer. So when we need a lower bound answer should be in lower bound. So take lower bound of numerator and the opposite of the denominator. So lower bound of the numerator is 24.5 and upper bound for the denominator is 0.35. So 24.5 divided by 0.35, which is 70. Okay, question number 21. Okay. The diagram shows three identical cuboids in a tower. The height of one cuboid is 6.5 correct to the nearest millimeter. So a unit conflict. So let's first change 6.5 to millimeters. So we get 650. We multiply it with 10. We get 650 millimeter. Now let's find its upper and lower bound as well. Add 0.5. 0.5 because this is 1 millimeter. We divide it with 2. So we get 0.5. Add 0.5 to get the upper bound, subtract 0.5 to get the lower bound. Okay. Then work out the upper bound for the height of the tower. So the height of the tower will be 3 times the upper value since they're asking for the upper bound. So 3 times 650.5 gives us, oh wait, there's a mistake. 6.5 times 10 is 65 millimeters. Add 0.5 to it, so we get 65.5, and subtract 0.5 to it, so we get 64.5. So this will be 65.5. So 3 times 65.5 is 196.5 millimeters. To change this into centimeters, divide it with 10, so 19.65 is the answer. Question 22. A rod has length 2.9 meters correct to the nearest 1 decimal place. What is the upper bound for the length of the rod? So 1 decimal means 0.1 divided by 2 is 0.05. For upper bound, add this value to the original value, so we get 22.95 is the answer for part 1. Part 2. Will the rod fit completely in a box of diagonal 3.02? Give reason for your answer. So if there's a box whose diagonal is 3.02, will this rod fit in? Of course it will fit in. It'll fit in diagonally and very comfortably because the rod is of length 2.95 maximum. Yes, so it will fit in, and why? Because of this, because 2.95 is less than 3.02. Okay. Question 23. The cost of making a chair is $28 correct to the nearest dollar. Calculate the lower and the upper bound for the cost of making 450 chairs. So cost of making a chair is $28 correct to the nearest dollar means add 0.5 to get the upper bound, subtract 0.5 to get the lower bound. Okay. And then calculate the lower and the upper bound for the cost of making 450 cards. So the upper will be 450 times 28.5 and the lower cost will be 450 times 27.5. So 450 times 28.5 gives us 12825, so we get this answer, and using this we'll probably get this answer. Okay. Question 24. A fence is made from 32 identical pieces of wood, each of length 2 meters correct to the nearest centimeters. So 32 identical pieces of wood, each of length 2 meters correct to the nearest 1 centimeter. So there's a unit conflict. I'll change meters to centimeters first and then figure out its upper and lower bound. So it was correct to the nearest 1 centimeter. Add 0.5, we get 200.5. Subtract 0.5, we get 199.5. Calculate the lower bound for the total length of the wood used to make the fence. So we need the lower bound answers. We have 32 identical pieces and the lower bound value is 199.5. So 32 times 199.5 is 6384 centimeters. sorry, yes, 6384 centimeters. We need to give the answer in meters, so that would be this answer right here. Okay. Question 25. Which is Ashraf takes 1500 steps to walk d meters from his home to the station. Each step is 90 centimeter correct to the nearest 10 centimeters. So 90 centimeters correct to the nearest 10 means 10 over 2 is 5. So the upper bound is 95 centimeter. The lower bound is 85 centimeters. Find the lower bound and the upper bound for D. So D would be 1500 steps, and for the upper bound answer multiply this with 95. For the lower bound answer multiply 1500 with 85, but the answers will be in centimeters. Divide them with 100. So 1500 times 95 is 142500 centimeters, and this would be 127500 centimeters. Divide these with 100 and divide this with 100 to get the answers in meters, because D should be in meters like mentioned here. Okay. Question 26. The volume of a cuboid is 878 correct to the nearest centimeter cube. The length of the base of the cuboid is 7 centimeter correct to the nearest centimeter. Okay, so 878 correct to the nearest centimeter cube. So the upper bound will be 878.5, lower will be 877.5. Yes. Then we have each, the length of the base of the cuboid is 7 centimeter correct to the nearest centimeter. So again upper is 7.5, lower is 6.5. Then we have width is 6 centimeter correct to the nearest centimeter. So this becomes 7.5, 6.5 and 5.5. Okay, calculate the lower bound for the height of the cuboid. So we know the formula for a cuboid. Volume is length times width times height. Now we need the value of height, so make height the subject. We get V over length times width. Now we need the lower bound for the height. So this needs to be lower bound, then the numerator needs to be in lower bound and the denominator needs to be in upper bound. So volume lower bound is 877.5 over length upper bound is 7.5 and width upper bound is 6.5. 877.5 divided by 7.5 times 6.5, which gives us 18. Answer for question 23. Okay, question number 27. Okay, 27. John wants to estimate the value of pi. He measures the circumference of the circular pizza as 105 centimeter and its diameter as 34 centimeter, both correct to the nearest centimeter. So 105 correct to the nearest centimeter means the upper bound will be 105.5, the lower bound will be 104.5, and the diameter is 34 correct to the nearest centimeter, so 34.5 and 33.5. Calculate the lower bound. Calculate the lower bound of his estimate of pi. Give your answer correct to 3 decimal place. So circumference equals 2 pi r. So circumference over 2r equals pi, or circumference over diameter equals pi. Now we need the lower bound for the value of pi. So if the if pi is lower bound, then numerator should be lower bound and denominator should be upper bound. So circumference lower bound is 104.5 and diameter upper bound is 34.5. Let's see what does this give us. 114.5 divided by 34.5, which gives 3.028 rounded off to 3 decimal place. So 3.028. Alright. Next part C for question 27 is the volume of a cylinder is 550, correct to the nearest 10 centimeter square. So 10 divided by 2 is 5, add 5 to it, we get 555, subtract 5 from it, we get 545. So this is the upper bound and lower bound volume. The height, this is the volume, the height can be 12 centimeter, correct to the nearest centimeter. So add 0.5 and subtract 0.5 to get upper and lower bound for the height. Calculate the upper bound for the radius of the can. Alright, so volume is for a can is pi r square h. Now we need the height. Calculate the upper bound for the radius of the can. So to find the radius, we'll take 4 and pi and h to the other side. This will become r square, then we'll take under root. Alright, so now we need the upper bound for the radius of the can. So to find the upper value here, we'll take the upper value in the numerator and lower values in the denominator. Okay, so now we substitute the values. Volume upper bound is 555. Pi will remain pi because this is not linked to part B. This is not a sub part of part B. So we don't have any upper bound value or lower bound value for pi right now. So, and the lower bound height is 11.5. So when you enter all of this in your calculator, you get 3.919. So you get this answer. Okay. Question 28. Anna walks 31 km at the speed of 5 km per hour. Both values are correct to the nearest whole number. So 31 km is actually 31.5 upper bound and 30.5 lower bound. Similarly, 5 km per hour is 5.5 upper bound and 4.5 lower bound. Okay, work out the upper bound for the time taken for Anna's journey. Time is distance over speed. So upper bound time, we need upper bound time, which means we need upper for the numerator and lower for the denominator. So 31.5 over 4.5. which gives us 7. Okay, question number 29. Asma runs 22 kilometers, correct to the nearest kilometer, so this becomes 22.5 and 21.5 upper and lower bound. She takes 2.5 hours, correct to the nearest half hour. So half hour is 0.5 hours, divided with 2 we get 0.25. So add 0.25 here and subtract 0.25 here. So we get 2.75 and 2.25 as the upper bound and the lower bound for time. Calculate the upper bound of Asma's speed. Speed is distance over time. We need the upper bound speed, which means we need upper bound distance and lower bound time. So distance will be upper bound 22.5 and time in lower bound is 2.25. Okay. So 22.5 divided by 2.25 is 10. Question 30. One lap of the racetrack measures 3720 meters, correct to the nearest 10 meters. So the upper bound will be plus 53725. The lower bound will be minus 53715. A car completes the lap in 75 seconds, correct to the nearest second. So 75, this was in meters. 75 second, correct to the nearest second means 75.5 and 74.5. Calculate the upper bound for the average speed of this car. Speed is distance over time. We need the upper bound. So distance in upper bound and time in lower bound. So 3725 divided by time in lower bound is 74.5. But we're not done yet. The question says give your answer in kilometers per hour. So I'll change my numerator from meters to kilometers by dividing it with 1000, and I'll change my denominator from seconds to minutes by dividing it with 3600. So I'll enter all of this in my calculator and I get 180, which is the answer for this part. Okay. Question 31. Which is, on a journey the train took 73 minutes, correct to the nearest minute. So 73 correct to the nearest minutes means 73.5 and 72.5. Okay. To travel 215 kilometers, travel to the nearest 5 kilometers, this is in minutes. This is 215 kilometer, correct to the nearest 5 kilometers. So add 2.5 to it, we get 217.5. Subtract 215 from 2.5 from it, we get 212.5. Upper bound and lower bound of the distance. Calculate the upper bound for the average speed. Average speed is distance, total distance over total time, and we need the upper bound for this. So that means we need upper bound of the numerator and lower bound for the denominator. So distance in upper bound is 73.5 and distance in upper bound is 217.5 and time in lower bound is 72.5. Again we need to convert this into kilometers per hour. So 217.5 is already in kilometers and 72.5 is in minutes divided with 60. So enter this fraction in your calculators. The answer is 180 kilometer per hour for part 31. Part 32. Ellie drives a car at a constant speed of 30 meters per second, correct to the nearest 5 meter per second. So the upper bound will be add 2.5 to it, and the lower bound will be subtract 2.5 from it. Okay. She maintains the speed for 5 minutes, correct to the nearest 10 seconds. Now a conflict in units. 5 minutes will be 5 times 60, which is 300 seconds, correct to the nearest 10 seconds. So add 5, we get 305 seconds. Subtract 5, we get 295 seconds. Calculate the upper bound for the distance in kilometer that Ellie traveled. So distance is speed times time, right? So the speed is 30 meters per second, and so we first need the value in upper bound. So we need the upper bound distance, and since we're multiplying two values to get the upper value, both the values chosen should be the upper values. So 32.5 meters per second times 30.5 seconds. So we get 32.5 times 30.5, which gives us 991.25 in meters. Now this is in meters, and we need the answer in calculate the upper bound of the distance in kilometers. So to get the answer in kilometer, we divide this with 1000. Oh, the answer here was 992.5. So divide this with 1000 to get the answer in kilometers, and we get this answer, 9.9125. Question number 32. Ellie drives a car at a constant speed of 30 meters per second, correct to the nearest 5 meters per second. So 5 divided by 2 is 2.5, added to 30, 32.5. Upper bound subtracted from 30, so 27.5 lower bound. This was meters per second, the speed. She maintains a speed for 5 minutes, correct to the nearest. I think we've done this question. Yes, we've already done this question. Let's start with question 33. Yes. Okay. The formula V equals U plus AT can be used to calculate the speed V of a car. U is 15, A is 2, and T is 8, each correct to the nearest integer. Calculate the upper bound for V. So we'll take upper values for all of these. U will become 15.5 plus A will become 2.2 times T will become 2.5 and 8.5. So add 0.5 to all of these values because it's correct to the nearest integer. Integer is one integer, divide 1 by 2, and we get 0.5. So for upper bound, add 0.5 to all of these values. 36.75 is the answer for 33. Okay, next up is 34. A is 10, correct to the nearest whole number. Whole number is 1. 1 divided by 2 is 0.5. Add to this, we get upper bound. Subtract to this, we get lower bound. This is A. Then we have H is 4, again correct to the nearest whole number. So 4.5 and 3.5, upper and lower bound. Work out the upper bound for the value of B. So first make B the subject. 2A divided by H equals B. We need the upper bound for B. So that means we need the upper bound for A and lower bound for H. So 2 times upper bound A is 10.5 and lower bound H is 3.5. 2 times 10.5 over 3.5. 6. 35. Part A, V is equals to IR is an experiment. In an experiment, I and R both measured correct to 1 decimal place, so 0.1 divided by 2 is 0.05. So we'll be adding this and subtracting this to get the upper and lower bound. Okay, find the lower. So 4 will be 4.05 or 3.95, and 2.7 will be 2.75 or 2.65. Okay. Then we have to find the in part A we have to find the lower bound for V. V equals IR. To get the lower bound here, we need lower bound here and lower bound here. So lower bound for I is 3.95 and lower bound for R is 2.65. So 3.95 times 2.65, 10.4675. 35B is S equals D by T. In an experiment, D and T are both measured correct to 2 significant figures. So keep this in mind. This is a tricky one. two significant figures, where D is 7.6. So correct to the two significant figure means this is the second significant figure, and which is at the position 0.1. Divide this with 2, this will give us 0.05. So the upper bound is 7.65 and the lower bound is 7.55. Similarly for T, we have T equals 0.23. Now the second significant figure is 3, which is at the position 0.01. So divided by 2 we get 0.005. Now add this to 0.23, we get 0. Let me write it somewhere else. Upper bound will be 0.235 and lower bound will be 0.225. Alright, by subtracting 0.005 and by adding 0.005 to 0.23. Alright, find the upper bound for S. Now S is distance over time. We need the upper bound for S, which means we need upper bound for distance and lower bound for time. So upper bound distance is 7.65 and lower bound time is 0.225. So what does this give us? 7.65 over 0.225. This gives us 34, which is the answer. Alright, that's all. I'll see you next time.